Hello everyone, welcome back to physics. Last time we were discussing about refraction of light. Okay, refraction is a phenomena in which light enters from one medium to another medium. It changes its path or it gets deviated from its path. That phenomena was called refraction of light. Okay, the extent of bending while light travels from one medium to another medium depends on a factor called refractive index. We have already discussed that in last lecture, that what actually refractive index is and what relative refractive index is. When we find out the refractive index of a medium with respect to air, then the refractive index is called absolute refractive index, and if we find out the refractive index of a medium with respect to another given medium, then the refractive index of that particular medium is called relative refractive index. That means refractive index of a medium, absolute refractive index of a medium, that was speed of light in air upon speed of light in medium. Similarly, for absolute relative refractive index, that means refractive index of medium 1 with respect to medium 2, that means light is entering from another medium except air. In this case, light was entering from air to a particular medium, that was M, and in this case light is entering in this medium, that consider this one is medium 1, from another medium 2. This is not air, okay, this is a medium apart from air. So in this case we define the relative refractive index, that is refractive index of first medium with respect to second medium. We use the same concept. We will use, in this case light was entering from air to this medium, so we used a speed of light in air upon a speed of light in medium. In this case light is entering in this medium 1 from medium 2, so we have to use a speed of light in medium 2, a speed of light in 2 upon a speed of light in 1. Okay. Further, if you want to solve this expression, just divide numerator and denominator by c, that is c. Speed of light in air is denoted by small c. So divide these two, denominator and numerator, both with c, by c, like speed of light in second medium whole divided by c, and this whole divided by a speed of light in 1 divided by c. This division will not affect this expression, since these both will get cancel out each other. Okay. Next one, if we focus on this term, that means numerator part and denominator part, you can see something like, consider this one. If you find out the refractive index of first medium with respect to air, that is absolute refractive index, what you will write here? That means c upon a speed of light in 1, a speed of light in 1, that is absolute refractive index of first medium. If we inverse, if we inverse both sides of this equation, that means this will result to 1 upon mu 1, that is equals to a speed of light in 1 upon c, and these two are the same. Similarly, for medium 2 we will replace 1 by 2. Okay, so we can replace the numerator part with absolute refractive index of medium 2 upon, sorry, this one was 1 upon absolute refractive index. So we can replace the numerator part as 1 upon absolute refractive index of medium 2 upon 1 upon absolute refractive index of medium 1, which will result to mu 1 over mu 2. That means if we have given the refractive index of these two media, then if we need to find the relative refractive index of first medium with respect to second medium, then we simply find out the ratio of their absolute refractive indices, and we get relative refractive index of first medium with respect to second medium. Okay. So we have to put one thing clear, that when we have to use absolute refractive index and when we should use the relative refractive index. Okay. If we find out the refractive index of one medium with respect to some another medium, we will simply go through relative refractive index, and if we find out the refractive index of a medium with respect to air, we will go through the absolute refractive index. Okay. So let's do some problem on the behalf of these two. Question number first, find out a speed of light in glass if refractive index of glass is 2.5. हमें ग्लास में स्पीड ऑफ लाइट फाइंड आउट करना है जहाँ पे ग्लास का रिफ्रैक्टिव इंडेक्स हमारे पास कितना गिवन है, 2.5 गिवन है. So simply go through the formula. We have to find out the refractive index of a glass. It is not mentioned here with respect to which medium, so we will consider air here. We will consider that the light is entering from air to glass. Okay. In this case, the refractive index of glass we can write down as C upon, that is C is the speed of light in air, upon a speed of light in glass. Light in glass, which will result to refractive index of glass. It is given as 2.5. That is equals to C 3 into 10 to the power 8. Let speed of light in glass is x. So x is equals to 3 into 10 raised to the power 5 divided by 10 to the power 8 divided by 2.5. Okay. Therefore x equals to 2.5 divided by 3. This will result to 1.0 1.2 into 10 raised to the power 8. Okay. This one is unit is meter per second. So another question is like, suppose question number 2. Light is entering from, consider this one is medium 1 and this one is medium 2. Light is entering from one medium to another medium and its path is not deviated or its path is not changed. If refractive index of first medium is x, what is the refractive index of second medium? Obviously, if the path of the light is not changed, that is light is not deviated from its path, that means there is no difference in refractive index of these two media. Therefore, the refractive index of these two media will remain same. So if the refractive index of first media is x, then refractive index of second media will also be x. Okay. So we can go through these problems, or we will provide you worksheet in this in which you can find out a lot of problems on the basis of refractive index and relative refractive index. You have to do that, or you can simply go through the book S. Chand publication physics, that is whose writer is Lakshmi Singh and Manjit Kaur. Hope you have already purchased that book. So go through the problems of topic refraction, refractive index and relative refractive index. If you face any doubt, you can ask me directly. Okay. So our next topic is laws of refraction. Laws of refraction. Just like reflection, there are two laws of reflection also. The first one is similar to the laws of reflection, that is the incident ray, the refracted ray, refracted ray and normal all lies on the same plane. Okay, and second one is the product of refractive index and sine of angle made with the normal remains constant. Normal remains constant for given two media of light propagation. That means जो हमारे पास दो मीडियम है जहाँ से लाइट ट्रेवल कर रही है, लाइट सपोज दिस वन इज मीडियम 1 एंड दिस वन इज सपोज मीडियम 2, ओके, और यहाँ पे रिफ्रैक्शन हो रहा है, तो इस केस में ऐसा होगा कि लाइट यहाँ से एंटर होगी और इसमें बेंड होकर समथिंग यहाँ पे पहुँचेगी. इन दिस केस कंसीडर दिस वन इज नॉर्मल, so this will be incident angle, that is angle of incident, and this one is angle of refraction. This medium must have some absolute refractive index, consider that is mu1 and this is mu2. Okay, so according to first law says that incident ray, refracted and normal, these all lie on the same plane. That means consider this one is incident ray, this one is refracted ray, and this one is normal, all will lie on the same plane, just as I discussed earlier in the laws of reflection. Okay, incident ray, reflected ray and normal all lies on the same plane. Similar to incident ray, refracted and normal, these all will lie on the same plane. Okay, the second law of reflection is the product of refractive index and sine of angle made with the normal. That means here the law is talking about absolute refractive index of the medium, where the refraction is happening. Okay, therefore we can go through second law as the product of refractive index for medium 1 and medium 2 both. For those both media where refraction is happening, we have to go through this, like product of refractive index and sine of angle made with the normal. For medium 1, sine of angle made with the normal is I, and here this one is R. So we can say that mu1 for first medium, that this one is mu1 into sine of angle, that is I, sine I. For second medium, mu2 into sine R, sine of angle made with the normal. This will remain constant. That means these values will not get affected. These values will remain same, which results to sine I over sine R, that is equals to sine I over sine R, that is equals to mu2 over mu1. And what is mu2 over mu1? We have already discussed earlier today that refractive index of first medium with respect to second medium, that is equals to refractive index of first medium upon refractive index of second medium. The same way we can go through that refractive index of second medium with respect to first medium. If we replace 1 by 2 and 2 by 1, then this will result to refractive index of second medium upon refractive index of first medium. Therefore, we can say that this is the relative refractive index of second medium with respect to first medium. Okay, and this one is sin I upon sin R equals to refractive index of second medium with respect to first medium, and this one is also known as Snell's law. This law is Snell's law. Okay, so these two are laws of refraction. Okay, next we will discuss the problems on the basis of laws of reflection, but not today. Wait for the next lecture. Till now, you have to focus. You have to study these topics and do problems related to refractive index and relative refractive index from the book I have suggested to you. Okay, and we will talk about the further topics later. Till now, thank you.